So what we talked about in 3.1 was measures of central tendency. And that's one way to look at and analyze statistics. We can look at all the numbers in the middle and see what they tell us. That's one way to look at it. Another way to look at it is how spread apart the data is. And we're talking about measures of variation. That's what we're talking about, and that's what 3.2 is all about. So how close the data is together tells us something about it. How spread apart the data is tells us something about it. And there's lots of different ways that we can look at it. Okay. One way that we use to determine how spread apart the data is the range. And the range is the difference between the highest data value and the lowest data value. So when you find the range, you actually do the subtraction. That's one of them. We're not going to use it too often, but you do need to know how to find it. The ones we're going to spend more time on are variance and standard deviation. And those are also ways to determine how spread out the data is. However, it's just spread out from the mean. What's important to notice here is that those two values have to do with how far away it is or how close it is to the mean. And to find the variance and standard deviation, we're going to use our graphing calculators. Okay, I'm going to show you the formula, but we're not going to do it by hand. We're going to let our calculators do it for us. And pretty simply, the bigger those numbers are, the more spread out the data is from the mean. And the opposite of that's going to be true too. The smaller those numbers are, the less spread out, or the closer they are to the mean. Okay? I'm going to show you an example of two data sets that have the exact same mean, but the data is spread out differently. So that having the mean doesn't tell us enough information about what's happening with the data. And we'll look at that example in a second. Here's an example, okay? We've got brand A and brand B of something. Doesn't matter what. It's not important, okay? What I want you to know is that the mean for each set of data is exactly the same. And I'm going to show you how we can use the variance and standard deviation, and range for that matter, for these problems to see a little more scientifically what's going on with the data, a little more empirically. Now I'm going to go through and explain what the standard deviation is and the variance is. We're going to go through those and we're going to look at the formulas, and then in the end we're going to use our graphing calculator to do the calculation, okay? So let's just try to get to a place where we have a little bit better understanding of what these things are. So first of all, the standard deviation is the square root of the variance. They are related that way. The standard deviation is the square root of the variance, which means also that the variance is the standard deviation squared. They have an inverse relationship, but squaring is involved. So if you're given the variance and you want to find the standard deviation, then you take the square root of the variance to get the standard deviation. If you are given the standard deviation and you're trying to find the variance, all you need to do is square the standard deviation. That's the relationship between them. And again, they are measures of variation, how spread out data is. Like, we're going to use the graphing calculator to find those. Okay, it's only going to give us the standard deviation in most cases, and we're going to need to calculate the variance. Some of our calculators will do both, and I'll show you where those are. And the other thing that you need to understand is there is a sample version of the variance and a sample version of standard deviation, and a population version of the variance and a population version of the standard deviation. And there's different symbolism. And I'm going to show you those. I'm going to show you the formulas just so you can see them and kind of where they're derived from. And then I'll show you how to use your calculator to find them. Now, so this is a population variance, okay? So there's a lot going on here. Sigma, this is a sigma, Greek letter sigma, lowercase sigma squared. This is an uppercase sigma, both Greek letters. Uppercase sigma means the sum of. So what this really means is you're going to take what happens, and again, our calculator is going to do it for you, but I want you to see where this formula comes from. You're taking the sum of the difference between each data value and the mean, and then you square each one. So if the mean was 35 and the data value was 60, I'd subtract them and square it. And I do that for every data value and add them up. And then divide that by the number of numbers, okay? If you were to do that by hand for any given data set, it would take you a lot of time and it would be a little bit excruciating, okay? And I'll be honest, the generation, my generation, and before me, that was the only way to do it. There was no graphing calculator to just type it all into. There was no computer program that I could type it into and it would do it for us. We had to do it by hand, okay? So that's the population variance. The sample variance is a little bit different. And the sample variance, the difference is I'm taking, so S is sample variance, and then this is still subtracted data value from the mean, but this is the sample mean. Okay, this was, if you remember from the video, this was the population mean, mu, and X bar is the sample mean, and then instead of dividing by n, you subtract 1 from n. Yeah, so n is the number in the data set, number of numbers in the data set. So the capital N, that would be all the numbers in the data set. N is the numbers in the sample data set, lowercase, and you just subtract 1. Again, I just wanted to show you where this comes from. You're subtracting the mean from each value, squaring it so that it's always positive number, and then you add those all up. Now, the standard deviation is just the square root of those. Okay, so when I'm looking for the standard deviation, it's just sigma is the standard deviation for the population, and it's just the square root of all of this. Again, the square root of sigma squared, which is the variance. That's where sigma comes in, and then the standard deviation for the sample is just S. And again, it's just the square root of all that. That's the relationship. Most of the time, you're going to take the variance and take the square root of it. If you're in your calculator doesn't have the variance, you'll just take the standard deviation and square it to get the variance. Yeah, I believe your calculators will only have standard deviation. You'll have to find the variance by squaring the standard deviation. Okay. Now, in the given problem, the problem itself will dictate whether you use the sample or the population. So when you're going through and you're working on these problems for homework, you're going to have to pay particular attention to what is being discussed in the problem. It might not explicitly say a sample, or it might not explicitly say population. You're going to have to glean that from the problem itself. So you're going to have to read and understand and decide if this means all of the possibilities or if this is a portion of them. Okay. So let's go back to our data set. Okay, and here's some of the type of information, some of the type of stuff you're going to have to find out. Okay, so there's 5 things that you're going to have to do for this problem for each set of data. We're going to calculate the range, we're going to calculate the population and sample variance, and we're going to calculate the population and sample standard deviation. And for the most part, we're going to do this on our calculator. Okay, the range, I don't know that we need a calculator for, but for this particular problem, but we'll kind of work through it. So for starters, give us a little setup here. Okay, so I've got A to the left, the 5 things that I need to find. B to the right, the 5 things that I need to find. And then I'm going to talk through how to find them. So again, notice I've set up everything here so I can keep it all straight. The range up on top, this stands for the population variance, the squared one, the population standard deviation, the sample variance, and the sample standard deviation. Okay? So you're going to have to get used to some of that notation and when to use them. Now, let's talk about how to do this on our calculator. Okay? And actually, let's do the range first before we even get there. The range is really easy. What's the biggest value in brand A?
16.
What's the smallest? 10. So what is the range? 50. You just subtract. Easy enough. Take the biggest minus the smallest. Okay. And then for B, what's the biggest one? 45. What's the smallest one? 25. Subtracted, what do I get? 20. Okay, so that measure of variance or variation, okay, based on that, which data seems like it's closer together? B. Okay, since the range is smaller, we would think, since they have the same mean, that those numbers are smashed closer together and that the numbers in A are spread further apart. Now, this may or may not be true because, for example, if we have something called an outlier, one number that doesn't fit with the rest of the data could make it seem like the range is more spread out, and so it might not always be the best indicator of a measure of variation, which is why we have variance and standard deviation as well to kind of see. So we're leaning toward the idea, and with our own eyes we can see that the data for B is bunched closer together than it is with A. But most of the time our data is not going to be 6 numbers, right? There's going to be a lot more data than that. So let's talk about how to enter all this into our calculator. Fortunately, we already have experience entering lists into our calculator. And so we're going to do the same thing. So if you recall, if you hit the stat button and then edit, you'll get your page with your lists. And for us today, let's enter brand A in list 1 and enter B in list 2. If you have data already in there, clear it out first. Don't delete it, clear it. And then enter that all in. And then after it's in, it's basically a couple clicks and we've got our answers, okay? So go ahead and do that. Enter that in to your list the way we did it before. When you go to do your calculations, you need to pay particular attention to where your data is. So in this case, we're going to focus on brand A, and that is in my list 1. So in order to get our calculator to do the calculations for us, what we're going to do now is we're going to hit the stat button again and arrow over to calculate at the top. And the very first menu item says, number 1 says 1 var stats. That means 1 variable statistics. And that's the thing that we're going to hit enter on. The key thing here is after you hit enter, it's going to designate which list are you finding it from. So for brand A, you have to make sure that what's after the colon there says L1. Okay? And so then you go down to calculate and hit enter. So it tells you the mean, the first one, the mean x bar, 35, which we already knew. Okay, we don't care about the sum of x and the sum of x squared. The next number down, S of x, is the sample standard deviation. Okay, so what is the sample standard deviation for A? Let's go 2. Yeah. 2 decimal places. 18.71. Did you get that? Okay, that's S right there in my calculator. Okay. Sigma is right underneath that, so that is the population standard deviation, and we'll call that 17.08. And I typed this in already, so I might have gone to only 1/10 of a place. Again, it is not my goal to get hung up on how many places you use. If you want to go more than 2, great. Okay, but your calculator will only give you the standard deviations, population, and sample. Okay. In order to get the variance, what do you think I need to do now? Square those. Okay, so go ahead and, if you haven't finished A, go ahead and do that. So that's what I got for the sample and population variance and mean, variance and standard deviation. So like I said, I rounded it to the 10th. Again, a general rule of thumb is to go 1 place beyond the data. Since the data is whole numbers, I added 1 decimal place past it. Again, I am not going to get hung up on however many decimal places you have. You should at least have 1 though, okay? You had that, okay? Now, for B, I do the same thing except since I've already entered the data into list 2, when you go to hit stat and calculate in one variable statistics, you have to change the list to list 2. And the list 2 abbreviation is above the number 2 in blue. So you just change it, and then it will do the calculation for list 2. So go ahead and do that. So, basic process, okay? What you should have gotten is that the population standard deviation was 6.5, the variance is 41.7, the sample standard deviation is 7.1, and the sample variance is 50. So as we suspected, since these numbers are all smaller, this number is bunched closer together. It's not spread out as much as this data is, okay? So I could identify more of a trend going on in brand B than we could in brand A because the data is more closely together, bunched more closely together. It's good for a situation when we actually know the data. Okay, however, as we know, oftentimes we have what we call group data. So a class, and they tell us how many numbers are in that class, but we don't specifically know the data. There is still a way to find the standard deviation and the variance from that, and it's kind of an ugly formula, and you're going to need to know how to do it. Okay, so made it easy for you with the situation where it's not group data. When we actually know the data, we'll take the calculator and have it do it for us. When we have group data, it's a different story. Okay, and this is the formula for the sample variance. Yeah, I'm going to explain what it all means, and we're going to put it all in a nice little table so you can help keep it all straight. I will tell you that with group data, we only talk about sample. Okay, we only talk about sample. There's no sort of population data for group data because we don't actually know the data. So we're talking about it just in terms of a sample. Let me explain what all this means, okay? This is the sum of, first of all, you take the number of data values, multiplied by the sum of the frequency of the midpoint squared. That's what x sub m means, the midpoint. So we're going to be taking the midpoints of each group.
Wait, is that x sub m squared?
Yep. So this is the sum of the frequency times the midpoint squared. Then we're going to subtract the sum of the frequency times the midpoint and then square all of it. So we square it on the inside, and then we square it on the outside, and then we divide by the number of data values times one less than that. And like I said, when I show you this little table, it's going to make it so much easier to keep straight.
So wait, x.
Yeah, x sub m is just the midpoint. We're going to use the midpoint for the group data. All right, and then of course, the standard deviation is just the square root of all that. Okay? We're going to find the variance for group data, and then using all the data that we have, that's where we're going to find the variance. We're going to have to derive the standard deviation. So opposite of what we did on the calculator, where the calculator gave us the standard deviation, we found the variance. In this case, we're going to find the variance and then use that to find the standard deviation. All right, so here's a data set. You'll want to write this down, okay? And notice the table, how it's set up. We've got our classes, we've got our frequency, we've got our midpoint, we have the frequency times the midpoint, and then we have the frequency times the midpoint squared. This table is critical to finding the variance and standard deviation, and it will help you keep things organized. So go ahead and find the midpoints, okay? Find the midpoints first. It's pretty straightforward. Like, what's the midpoint for 5.5 and 10.5? 8. Okay. Then what's the next one down? 13. Then they go up by how much? 5. My midpoints, it starts at 8, 13, and then once you start seeing what they go up by, you can pretty much not worry about it. Once you find those midpoints, our next thing is to multiply the frequency times the midpoint. So that's what this column is. multiplying these two things together. So go ahead and do that. So when I multiply those all down, I end up getting 8, 26, 54, 115, 112, 99, and 76. Again, all these numbers are just these two columns multiplied together. Okay? Now the difference between this column is I have to square the midpoint first and then multiply it by the frequency. Okay? Square the midpoint first and then multiply it by the frequency. That's going to give me this one. And notice that that's what's in this formula. The sum, so I'm going to have to end up taking the sum of all. So this is, first one's going to give me 64. This one's going to be 169 times 2. This one's going to be, I don't know what 18 squared is, times 3. And so I'm just going to give you those. Okay? All right. So that is, again, that's the midpoint squared times the frequency. So go ahead and get those numbers down. So again, here's what we found. So this one is the frequency times the midpoint squared, which is this column. This is the frequency times the midpoint, which is this column. I need the sum of those columns. So I need to add these two columns up. I need the sum of this column and the sum of this column. And that's what that all gives me. Okay, so the sum of this column here is just 490 when you add these up. The sum of this column here is 13,310, and the sum of the frequencies is 20, because I'm going to need that here. So I have everything I need now to plug into this formula. Okay? So the n is 20, the n minus 1 is what? 19. The sum of the frequency times the midpoint squared is this number right here. Okay, so that's going to go up in these parentheses here. The sum of the frequency times the midpoint is 490, and then I'm going to end up squaring that. Okay, so when I enter that all in and I put that into the formula, here's what it looks like. Okay, and I've highlighted the numbers where they came from and where they go. Okay, so this 13,310. Okay, this number goes here, which is right here. The sum of the frequency times the midpoint was 490, and notice it's squared because of this squared here. The n is 20, and then I've got 20 times 19. I'm almost there. Okay, then it's a matter of typing all that in the calculator and seeing what we get. Okay, so in this first one, for the variance, I get 68.7. Okay, that is the standard. That's the variance. Standard deviation is just the square root of that. 68.7, which is approximately 8.3. Okay, and that's what it takes in order to find the standard deviation and variance from a set of group data. It's a lot more involved. So think about it this way. That little story I told you about back in the day when we had to find standard deviation and variance without a calculator because we only could do it by hand, the only way to do this one is by hand. So at least we saved you half of it. Okay?